Hi and welcome to the next session of heat transfer. Today we study the heat exchangers. So first thing, what is meant by heat exchanger? A heat exchanger is a device used for transfer the heat from high temperature fluid to the low temperature fluid, which both fluids are moved through the same device. Means to transfer the heat from the one fluid to the another fluid, we use the heat exchanger. So here first, hot fluid is flow through the pipe and the cold fluid flowing around this pipe. Here, the both fluid move from the left to right, means this is the parallel flow heat exchangers. The types of heat exchangers. So what are the different types of heat exchanger that we study here? The types of heat exchanger. First is the parallel flow heat exchanger. Why this heat exchanger called parallel flow? Because here hot fluid and a cold fluid both moves are in the same direction. That's why it's called a parallel flow heat exchanger. Another heat exchanger is the counter flow heat exchanger. Here, hot fluid moves from left to right and the cold fluid moves from right to left. So that's why it's a counter flow heat exchangers. Means that their flow is in opposite direction. This outer portion is called annulus pipe and the inner portion is called the central tube. Now we study the analysis of the heat exchanger. The most important topic for the gate is the log mean temperature difference. First we study for the parallel flow and then for the counter flow. The first things, this is the diagram for the parallel flow heat exchangers. Here hot and cold fluid moves in the same direction. So that's why it's called parallel flow. Now we draw the temperature distribution over this plate. It having distance from inlet, means here we having the 0 and here we having the L, that is the length. The hot fluid flows from left to right, so this is the curve. Means hot fluid exchange the heat with the cold fluid, means its temperature goes down. That's why this curve moves from higher to lower, and it having the inlet temperature TH1 and outlet temperature TH2. Another one is cold fluid, which move from the left to right. Here it's gain the heat from the hot fluid, that's why its temperature will get increased. It having the inlet temperature TC1 and the outlet temperature TC2. The temperature difference between TH1 and TC1 is called delta T1, and temperature difference between TH2 minus TC2, that will be the delta T2. Now how to find the log mean temperature? The formula for the log mean temperature difference is LMTD or delta Tm is equal to delta T1 minus delta T2 upon in log delta T1 upon delta T2. Means we have to find first delta T1 and then delta T2, then subtract that and put in the log, we get the answer. Here where delta T1 will be this TH1 minus TC1, delta T2 equal to TH2 minus TC2. Now next we find the log mean temperature difference for the counter flow. Here we having the counter flow diagram. So that will be here hot fluid move from the left to right and a cold fluid move from the right to left. Means hot fluid exchange the heat with cold fluid, means here hot fluid move from the left to right, that's why it curve move from the left to right and its temperature decreases. It's called hot fluid. Delta TH1 it's a higher temperature, it's the inlet temperature of the hot fluid, and delta T2 is the outlet temperature. Cold fluid is temperature distribution move from right to left. It having the inlet temperature on the right, that is TC1, and the outlet temperature at TC2. Only difference between the parallel flow and the counter flow is here we have TC2 and here we have TC1. Means in the left hand side we have TC2, means the outlet temperature, and here on the right hand side we have TC1. That's the difference. And delta T1 is the same here, means TH1 minus TC2, and delta T2 will be TH2 minus TC1. So to find the LMTD we have the same formula, that is LMTD is equal to delta T1 minus delta T2 upon in log delta T1 upon delta T2. So where delta T1 equal to TH1 minus TC2, means this temperature difference, and the delta T2 will be TH2 minus TC1, this temperature difference. Today we understand the log mean temperature difference for parallel flow and counter flow.